A medieval sword could bend nearly 40 degrees and still return to its original shape. A modern steel blade, made with advanced machinery and precise chemistry, can snap in half under the same stress. That sounds impossible. It sounds like a myth, but it isn't. For centuries, people believed that medieval weapons were crude, poorly made, and inferior to anything we can produce today. We imagine blacksmiths guessing blindly, hammering metal in the dark, hoping it would work. And yet, when historians, engineers, and modern bladesmiths began testing surviving medieval swords, something unsettling happened. These blades didn't shatter. They didn't explode into fragments. Instead, they bent, absorbed the force, and survived. And that raises an uncomfortable question. If modern steel is stronger, if modern science is more advanced, why did medieval swords fail less catastrophically than many modern blades? The answer is not that medieval steel was magically superior. It's something far more disturbing than that. Medieval sword makers were not trying to make the hardest steel possible. They were trying to make steel that survived mistakes, chaos, and violence. They understood something about failure that we no longer design for. In battle, a sword does not face clean laboratory conditions. It collides with armor, bone, shields, other blades. It strikes at bad angles. It hits too hard. It gets twisted, stressed, and abused. A blade that is too hard becomes brittle, and brittle steel doesn't warn you before it fails. It simply breaks. When a sword shatters, it's not just damaged, it's gone. And in medieval combat, that could mean death within seconds. So, medieval sword makers made a different choice. They accepted bending. They accepted deformation. Because a bent sword could be straightened. A chipped edge could be reforged. A living blade could be repaired. A shattered one could not. This mindset runs completely opposite to modern expectations. Today, we associate quality with rigidity, with stiffness, with materials that never change shape. But medieval craftsmen judged quality by how something failed, not by whether it failed at all. Their goal was not perfection. Their goal was survival. What makes this even more astonishing is that medieval blacksmiths achieved this without microscopes, without stress analysis software, without chemical formulas. They didn't measure carbon content in percentages. They didn't read textbooks on metallurgy. They learned through generations of failure, observation, and brutal feedback from real use. They watched blades bend instead of break, and they learned. They saw shattered steel, and they avoided it. They listened to the sound of the hammer, watched the color of heated metal, and judged strength by experience, not theory. The result was not a super sword. It was something far more practical. A blade that forgave mistakes. A blade that absorbed violence. A blade that stayed alive when everything went wrong. And swords were only the beginning. Because the same forgotten logic shaped medieval tools, armor, chains, and ironwork. Objects that were not designed to look perfect, but to endure fire, war, and time itself. To understand why medieval swords rarely shattered, we must first unlearn what we think strength really means. To understand why medieval steel swords rarely shattered, we have to abandon one of the most common assumptions about metal, that harder is always better. In the modern world, hardness is often treated as the ultimate proof of quality. Hard tools feel solid. Hard blades feel sharp and permanent. Hard materials promise control. But in real combat, hardness is not strength. Hardness is risk. A sword does not fight air, it fights chaos. On a medieval battlefield, no strike is clean. Blades slam into shields, glance off helmets, collide edge to edge, twist under pressure, and strike bone at bad angles. Every one of those moments introduces shock. and shock is what destroys brittle steel. When steel is hardened too much, it loses its ability to absorb energy. Instead of flexing, it resists, and resistance concentrates stress into a single instant. That is when steel fails without warning. Medieval sword makers understood this intuitively, even if they lacked the language to explain it scientifically. They knew that a blade that refused to bend was a blade that would one day break, and they knew that breakage was not an option. In medieval warfare, a shattered sword was not an inconvenience. It was a death sentence. There was no backup weapon rack, no quick replacement. A soldier whose blade snapped was suddenly unarmed in a world that did not forgive hesitation. So, medieval craftsmen made a deliberate choice. They sacrificed extreme hardness to gain resilience. A medieval sword was designed to deform before it failed. When overloaded, it bent. When struck poorly, it flexed. When abused, it survived long enough to be repaired. This was not a flaw, it was the entire point. This concept is known today as toughness, the ability of a material to absorb energy without fracturing. Toughness is not glamorous, it doesn't photograph well, it doesn't feel impressive in the hand, but it keeps objects alive under real conditions. Medieval sword makers optimized for toughness because reality demanded it. What makes this even more fascinating is how different this approach is from many modern steel products. Today, steel is often engineered for predictable environments: factories, machines, standardized loads. Blades are hardened for sharpness and edge retention, sometimes at the expense of shock resistance. In controlled use, this works beautifully. But when modern steel leaves its intended environment and enters unpredictable stress, it can fail suddenly and violently. Medieval swords were never meant for controlled conditions. They were meant for the worst possible day of a person's life. That is why medieval blades often show signs of flexibility in historical tests. When modern researchers apply force, the blade bends and returns, instead of cracking. This elasticity spreads stress across the length of the sword, rather than concentrating it at a single weak point. Stress that spreads rarely destroys. Stress that concentrates almost always does, but toughness alone is not enough. A sword that is too soft will bend permanently, lose its edge, and become useless. Medieval sword makers had to balance two opposing needs: a blade that was hard enough to cut and soft enough to survive. This balance is where their true skill appears. Rather than treating the sword as a single uniform object, medieval craftsmen treated it as a system. Different parts of the blade were expected to do different jobs. The edge needed hardness, the body needed flexibility, the core needed to absorb shock. This layered thinking allowed the sword to behave differently under different stresses, responding intelligently instead of catastrophically. Modern metallurgy recognizes this as an advanced design philosophy. Medieval smiths arrived at it through experience, not equations. They learned by watching blades fail. They learned by seeing where cracks formed. They learned by listening to the sound steel made when struck. Over generations, they refined their methods until swords behaved predictably under violence. Not perfectly, but survivably. And survival was everything. The modern world often celebrates materials that never change shape. Medieval craftsmen trusted materials that could adapt. A sword that bends tells you it is under stress. It gives warning. It gives time. A sword that shatters gives nothing. This difference reveals something deeper than metallurgy. It reveals a different relationship with failure. Medieval design accepted failure as inevitable and planned for it. Modern design often pretends failure won't happen at all. That is why medieval swords rarely shattered. Not because they were stronger in the modern sense, but because they were wiser. They were built for the moment when everything went wrong, and that moment was expected, not ignored. And once we understand that, the next question becomes unavoidable. How did medieval blacksmiths control steel so precisely without science, without instruments, and without numbers?
Hard enough to cut.
One of the biggest mistakes we make when judging medieval swords is assuming they were made from a single, uniform block of steel. That assumption feels logical to a modern mind, because modern manufacturing values consistency above all else. One alloy, one specification, one controlled process. But medieval sword makers did not think this way at all. To them, a sword was not an object, it was a structure. Medieval blades were often built from multiple types of iron and steel, deliberately combined into a single weapon. Each material had a role to play. Some parts were hard, some parts were soft, some were flexible. Others were resistant to wear. Instead of forcing one type of steel to do everything, medieval smiths allowed different materials to share the burden. This is one of the most important reasons medieval swords rarely shattered. At the heart of many medieval blades was a softer, low-carbon iron core. This core acted like a shock absorber. When the sword struck something solid, armor, shield, bone, the core helped dissipate energy through the length of the blade instead of letting it concentrate in one brittle point. Around this core, harder steel was forge welded to form the cutting edges. These edges held sharpness, while the inner structure kept the blade alive. In other words, medieval swords were layered by design. This technique is often referred to as pattern welding, though it was not done for decoration alone. The visible patterns we admire today, twisting lines, flowing waves, layered textures, were not aesthetic choices at first. They were structural evidence. They showed that different metals had been folded, stacked, and welded together to create a blade that behaved intelligently under stress. Each layer responded differently to force. Hard layers resisted wear. Soft layers absorbed shock. Transitional layers prevented cracks from traveling through the blade. When stress tried to tear the sword apart, it was forced to change direction again and again. That interruption alone could stop catastrophic failure. A crack that cannot travel is a crack that cannot kill a sword. Modern engineers recognize this principle instantly. Layered composites are used in aircraft, armor, and safety equipment for exactly the same reason. They prevent sudden failure. Medieval sword makers arrived at the same solution centuries earlier, without knowing the mathematics behind it. They discovered it the hard way. When early blades cracked, smiths learned which materials failed first. When swords bent too easily, they adjusted the balance. When edges chipped, they refined carbon content. Over time, sword construction evolved into a sophisticated compromise between strength, flexibility, and repairability. This also explains why medieval swords often look inconsistent when examined today. Carbon content varied. Grain structures differed. Some blades show imperfections that would horrify modern manufacturers. But those imperfections were often the byproduct of intentional variation. Uniformity was not the goal. Function was. A perfectly uniform blade fails uniformly. A layered blade fails gradually. Gradual failure is survivable. It is also important to understand that medieval sword makers worked with imperfect materials. Iron ore quality varied wildly. Smelting techniques were inconsistent. Steel could not be produced in large, standardized batches. Instead of fighting these limitations, medieval smiths adapted to them. They selected, combined, and positioned materials based on behavior, not purity. This adaptability became a hidden advantage. Modern steel relies on precision. Medieval steel relied on judgment. When a smith layered different steels, he could place toughness where it mattered most and hardness where it mattered least. The sword became tolerant of abuse. It could flex, twist, and recover. Even when damaged, it could often be reforged, repaired, and returned to service. This made swords long-lived tools rather than disposable products. A medieval sword was expected to age. Modern blades are often designed to perform perfectly until they don't. When they fail completely. Medieval blades were designed to degrade gracefully. That single difference changes everything. What we are seeing in medieval sword construction is not primitive metallurgy. It is adaptive engineering. It is the refusal to trust any single material with total responsibility. Instead, responsibility is shared. And this philosophy did not stop at swords. The same layered thinking appeared in medieval armor, tools, chains, and iron structures. Metal was not forced to behave perfectly. It was allowed to behave honestly. But structure alone was not enough. Even the best layered blade could be ruined by one mistake in heat. And medieval blacksmiths, without thermometers or scientific charts, somehow learned to control fire with terrifying precision. That is where the real secret begins. If layered steel gave a medieval sword its structure, heat gave it life. And this is where the modern mind struggles the most. Today, heat treatment is a science measured in exact temperatures, controlled atmospheres, and digital precision. Medieval blacksmiths had none of this. No thermometers, no charts, no equations. And yet, they consistently produced blades that balanced hardness and flexibility with remarkable reliability. They did it by learning how steel behaved when it was alive. To a medieval blacksmith, fire was not a tool you controlled with numbers. It was a force you learned to read. Heated steel spoke through color, movement, sound, and reaction. A blade, glowing dull red, told a different story than one glowing bright orange. The way sparks flew when metal was struck or ground revealed its carbon content. Even the sound of a hammer blow changed depending on temperature. This sensory knowledge replaced instruments. When modern people imagine medieval quenching, they often picture a dramatic plunge into water, steel screaming as it hardens instantly. That image is incomplete. Medieval smiths knew that full quenching could destroy a blade if done blindly. Steel hardened too quickly becomes brittle. Brittle steel shatters. So, quenching was often partial, controlled, and intentional. In many cases, only the edges of a sword were fully hardened. The spine and core were allowed to cool more slowly, retaining flexibility. This differential heat treatment created blades that could cut aggressively while still absorbing shock. It was not an accident. It was learned behavior passed from master to apprentice. A sword that cracked during quenching taught a brutal lesson. That knowledge stayed. Tempering was equally critical. After hardening, blades were gently reheated to reduce brittleness. Again, no thermometers. Instead, blacksmiths watched for subtle color changes on the steel's surface: straw yellow, brown, purple, blue. Each color corresponded to a different balance of hardness and toughness. These colors were not decoration. They were warnings and guides. Too pale, and the blade stayed brittle. Too dark, and the edge lost its bite. This meant every sword demanded attention. Heat could not be rushed. A distracted smith ruined steel. A patient one created a weapon that survived war. What makes this process extraordinary is not that medieval blacksmiths sometimes succeeded. It's that they succeeded often enough to standardize these techniques across regions and centuries. From Scandinavia to Central Europe, similar principles emerged independently. Not because of shared textbooks, but because steel behaves the same way everywhere when pushed to its limits. Medieval smiths learned to respect those limits. Modern steel production often removes this intimacy. Machines control heat. Algorithms define curves. Workers oversee processes rather than engage with material directly. The result is consistency, but also distance. Medieval swordmakers were never distant from failure. They stood inches away from it every time they quenched a blade. That proximity sharpened judgment. It also explains why medieval swords rarely shattered in use. Because the steel was never pushed to the edge of brittleness without restraint. Hardness was always negotiated, never maximized. Flexibility was preserved intentionally. A blade was allowed to remain imperfect in order to remain alive. This approach also made medieval swords forgiving. If one section of the blade was overheated or over-hardened, the layered structure and tempered core could compensate. Failure was localized rather than total. Modern uniform steel lacks this margin. When it fails, it often fails everywhere at once. In medieval metallurgy, fire was not a blunt force. It was a language, and blacksmiths were fluent. They understood that steel remembers heat. Every flame leaves a trace. Every mistake has consequences. And so, heat was applied with caution, patience, and respect. This mindset turned unpredictable fire into a reliable partner. Without this mastery of heat, layered steel would have meant nothing. Structure without behavior is fragile. Heat treatment gave medieval swords their final balance, the point where edge, core, and spine worked together instead of against each other. But even this was not the end of the story, because a medieval sword was never finished when it left the forge. Its survival depended not only on how it was made, but on how it was used, repaired, and expected to endure. Even the best-made medieval sword was never expected to remain flawless. That idea alone separates medieval metallurgy from modern thinking more than any technical detail. Today, we design objects to look perfect and stay perfect for as long as possible. When they stop being perfect, we replace them. Medieval people lived by the opposite rule. They expected damage, and because they expected it, they planned for survival. A medieval sword was not a disposable product. It was a long-term companion. On the battlefield, damage was inevitable. Edges chipped, blades bent. Nicks appeared after striking armor or another sword. But none of this meant the weapon was finished. In fact, most of this damage was considered normal. A sword that showed wear was a sword that had done its job. This expectation changed everything. Because medieval swordmakers knew their blades would be damaged, they did not design them to resist damage at all costs. They designed them to fail safely. A bent blade could be straightened. A chipped edge could be ground back and reforged. A sword that lost a little length over years of resharpening was still better than one that shattered once and disappeared forever. This is one of the quiet reasons medieval swords rarely shattered. They were constantly maintained, adjusted, and renewed. Maintenance was not optional, it was part of ownership. A sword that went dull was sharpened. A blade that warped was corrected. Even significant damage could be repaired by reheating and reworking sections of the steel. Medieval smiths understood their material well enough to bring it back from the brink again and again. This culture of repair created a feedback loop. Damage taught lessons. Each repair revealed weaknesses. Over time, both sword and swordmaker improved. Modern weapons and tools rarely benefit from this loop. When something breaks today, it is often cheaper to replace than to repair. As a result, designs no longer prioritize repairability. Thin margins, extreme hardness, and uniform materials leave little room for correction. When failure comes, it comes suddenly and completely. Medieval swords lived in a different world. They were expected to survive poor strikes, bad angles, exhaustion, fear, and chaos. No warrior fought perfectly. No battle unfolded as planned. A sword that required ideal conditions to survive would be useless. So medieval blades were built with forgiveness in mind. This forgiveness extended beyond metallurgy into behavior. Warriors learned how their swords reacted under stress. They felt when a blade flexed. They noticed changes in balance after repairs. They adapted their fighting to the sword's condition. The sword was not a static object. It evolved alongside its owner. This relationship mattered. A warrior trusted a sword that had survived past battles. That trust was earned through endurance, not appearance. And endurance came from design choices that favored resilience over brilliance. This also explains why medieval swords often look unimpressive when judged by modern standards. They are not mirror perfect. They show asymmetries. Some have uneven edges or subtle warps, but these traits did not weaken them. They made them real. A blade that had been sharpened dozens of times, repaired after impact, and kept alive through care, carried knowledge within its steel. It knew how to survive. Contrast this with many modern blades, optimized for showroom sharpness and initial performance. They cut beautifully, until they don't. When pushed beyond their narrow design limits, they fracture. There is no second life, no correction, no learning. Medieval swords endured because people expected them to endure. They were made, used, damaged, repaired, and used again. Every cycle reduced the chance of catastrophic failure. Weak steel was removed, brittle sections were softened, stress points were discovered and corrected. By the time a sword finally failed completely, it had often served for decades. So, when we ask why medieval swords rarely shattered, part of the answer has nothing to do with steel composition or heat treatment. It lies in expectation. Medieval people did not believe in perfection. They believed in continuity. And continuity is the enemy of sudden failure. But this raises a final, uncomfortable thought. If medieval swords survived because they were designed for reality rather than ideals, what does that say about how we design things today? That question brings us to the conclusion, and to what medieval steel ultimately teaches us about strength itself. By now, it should be clear that medieval swords rarely shattered, not because they were stronger in the modern sense, but because they were built with a completely different philosophy. Medieval craftsmen did not chase maximum hardness, perfect symmetry, or laboratory-grade consistency. They chased survival. Every choice made in a medieval sword pointed toward the same goal. Layered steel spread stress instead of concentrating it. Controlled heat created balance instead of brittleness. Maintenance and repair extended life instead of ending it. None of this was accidental. It was a system shaped by necessity, violence, and consequence. Modern steel, by contrast, is often designed for predictability in controlled environments. It excels when loads are known, angles are clean, and conditions are stable. But combat is none of those things. Real life is none of those things. Medieval sword makers understood this long before engineers had equations to describe it. They accepted that failure would happen. And because they accepted it, they planned for how failure should look. A medieval sword was allowed to bend so it would not break. It was allowed to scar so it would not die. It was allowed to change shape over time because change meant survival. This is the opposite of modern design culture, which often hides fragility behind perfection until collapse is sudden and irreversible. Strength, in the medieval sense, was not resistance. It was adaptability. This idea reaches far beyond swords. The same thinking shaped medieval tools, armor, chains, and buildings. Objects were expected to age, to be repaired, to pass through many hands. They were part of a long timeline, not a short product cycle. Metal was valuable, time was expensive, waste was unacceptable. That is why medieval steel still speaks to us today. When we test surviving swords, we are not just testing metallurgy, we are testing a worldview. A worldview that valued resilience over brilliance, endurance over appearance, and function over perfection. Medieval craftsmen did not have the luxury of pretending failure wouldn't happen. Their lives depended on preparing for it. And perhaps that is the lesson modern society struggles with most. We build many things today that perform beautifully until they don't. When they fail completely. Medieval swords rarely shattered because they were never asked to be flawless. They were asked to endure. Understanding this does not mean rejecting modern science or technology. It means remembering what technology is for. Tools exist to serve humans in imperfect conditions. When they forget that purpose, they become fragile. Medieval steel was not primitive, it was honest. And once we see that honesty, we begin to understand why swords were only the beginning, and why so many medieval tools still outlast their modern descendants.